Solve f of x less than or equal to g of x, given f of x equals x to the fourth minus 1 and g of x equals negative 2x squared plus 2. So all we have to do here is just sub in each piece. So for instance, my f of x equals x to the fourth minus 1. So I'm just going to write that here. And that's going to be x to the fourth minus 1. And then that's less than or equal to from there. And then I have my g of x, which is here. So there's my g of x. And that's going to be negative 2x squared plus 2. And then all I have to do from here is the same thing I did in the last video if you watched it. I just have to move everything over to the same side. So I always try to keep the largest degree term positive. It just helps in factoring for the most part. So that means I'm going to add 2x squared and subtract 2 to both sides because I want it 0 over here. And I want everything to be on this side. All right, so I'm going to add 2x squared minus 2 to both sides. And on the left side, I'm going to get x to the fourth plus 2x squared minus 3 less than or equal to 0. So now keep this in mind. Also, I noticed I put it in descending powers again too. It's very important that I put it in those steps because when I get to factoring, it just helps a ton. Now remember, I also said that when I have the powers here, they don't necessarily have to be a 2, but that power in the middle has to be half of the power, and the number on the end has to be a number. And that tells me there that I'm dealing with my pattern. At least for the most part it does. There's some special examples where this doesn't have to just be a number on the end, but that's usually introducing 2 variables. And we're not getting into that here, so I'm not going to touch that. So anyways, so now I'm just going to factor this like I normally would factor stuff because it has that pattern to it. So that's going to be an x squared. And think about it, that's going to be an x squared because that's going to give me an x to the fourth. And when I add those together, notice I'm just going to get these squareds, and that's a squared. So that's why it works out. Okay, so anyway, so this is going to be a plus 3, and then it's going to be a minus 1. Signs have to be different because this is a negative 3. And 3 and 1 are factors of 3. Okay, and that's less than or equal to 0. And now this can be factored some more now also. So I take a look at this, x squared minus 1, that can be factored. So the biggest thing here when I'm dealing with these polynomials is I have to be comfortable with factoring. And I have to know my factoring. So there it is. So that was a difference of squares. So it's x plus 1, x minus 1. So now we factored as far as we can. And that's another thing we got to be confident of, that we actually factored as far as we could. When I look at this here, x squared plus 3, I know that's prime. So that's something we should also know. But that might help when we went through the complex 0 section. Because if we notice, that would be a complex factorization if we did it. Okay, so anyways, let's get back to this problem. Now we're just looking for the number line. And then we're going to put all of our zeros on there. This will never be 0 in the real numbers, so I don't have to worry about it because it's prime. Okay, and since we're dealing with this section of math, it doesn't deal with the idea of complex zeros. So here we have negative 1. And then here we have a positive 1. So those are our only 2. It's kind of nice to only have a few, considering the last problems we did. So now I'm going to pick my test points. So I'll pick negative 2 and 0. I always like to pick 0 when I can. And then also 2. And then I'm just going to run through the process here. Now, since I'm squaring it, it doesn't matter what I plug in there. It's always going to be positive. And this is a plus 3. So it's not going to matter what I plug in. This will always be positive. So I don't have to ever change that. That's kind of nice when I run across those scenarios there where, oh, okay. Once I run through positive or negative, since it's just a square plus 3, and if that was a minus 3, this was a minus here, then that would always be negative. So it's kind of nice to pick up. Actually, I'd be able to factor it more if it was a minus. So stop that. Okay, so anyways, So let's get to the rest of this. I'm just letting you know I'm just going to keep a positive there because it doesn't matter what I plug in, it's always going to stay positive. And you can see the test points when you plug them in that would always be true. All right, so we're going to plug in the -2 first, so we're here. So that means that's going to be negative, and that's going to be negative. So it's an even number of negative, so it's positive. All right, so let's try the next one now. Now we're going to try 0. So when I plug in, and we're clicking that test point. So that's going to be positive, and that's going to be negative. So I have an odd number of negatives, so that's going to be negative. And then the last one is the 2 here. Oops. And that means we get positive and positive. So it's positive. So we get positive, negative, positive on our intervals. Okay, so we're looking at where this is less than or equal to 0. So that means it's going to be negative or it can equal 0. So I look where it's negative or it can equal 0. And that's only right here in the middle. That's where we see the negative sign at. So it's between -1 and 1. Now, since these are actually zeros, they're not asymptotes or anything, we can include those n values because of this equal sign. So with these with the polynomials, we can be a little more relaxed with the n values. We still have to represent them correctly, but we get -1 to 1. But we don't have to worry about, oh, is it a parenthesis or a bracket when it's equal to? Polynomials, since it's the domain is all real numbers, we don't have those issues to even consider. With the rational functions, we do because we have asymptotes. So there's our answer for this one right here. All right.